Good evening and welcome to tonight's webinar titled Want to Know a Secret, where presenters Craig Brown and Chris Eisen will demonstrate how using widgets and user-defined functions can lead to efficiently use of TI-nspire calculated by your students. I'm Daisy Patsis and I'm your host tonight. And today's panelists, we have Craig Brown, which you may have heard in previous webinars, comes with a lot of experience, as well as Chris Eisen also comes with a wealth of experience, both teaching, and in fact both gentlemen just returned from an international T-Cubed conference that was held in Baltimore this year. They both presented wonderful sessions. To hand over to Craig to get us started.
Thank you, Daisy. I'm hoping to share my screen. How does that look, Daisy?
Terrific.
Okay.
You're all ready to go.
Thank you very much. Okay, welcome everybody. My part of the webinar this evening is to hopefully inspire you in using some widgets and maybe give you some good ideas, and one in how to create them and two how to use them in our classes. So my first job is going tonight is to make one. That's the main thing when it's all said and done. How do we actually create a widget? A widget is simply a document that we actually have to create. So the first thing we're going to do is create a new document. So I'm going to go New Document, and I'm going to start off my widget with a Lists and Spreadsheets page. So my example tonight will in fact be a stats focus, univariate stats, but probably the main thing is that we need to perhaps take more consideration of how the pages interact with one another and how we actually save the widget and access it. So that's probably the most important part of tonight's focus, really. So we'll start off with some a Lists and Spreadsheets page. I'm going to create a variable called data, and I'm going to put in some numbers, basically some test numbers. So we'll go 5, 10, 15, and 20, and 25. So I've just punched some numbers in. What I'm now going to do is I'm going to insert a notes page. Now I'm a real fan of notes page because of the fact of the dynamic nature of them, where they automatically update, and hopefully if you haven't been a user of these in the past, maybe you will be inspired to experiment with them after tonight. Okay, so what I'm going to do is title this page Results. Oops. Results. Now I'm going to insert a maths box. There are a few ways to insert a maths box, but basically the shortcut is to press Control-N. And in this maths box, we're going to have the results of the univariate statistics calculated. So if I hit Menu, go down to Calculations, down to Statistics, over to Stat Calculations, and lastly, one variable statistics. Number of lists I'm calculating these on is 1, and the variable that I in fact am calculating these is data. And I'm going to press OK. There's our results displayed in that matrix. What I might now do is insert another page. This time I'm going to in fact choose a data and statistics page where I'm in fact going to come up with some sort of graph. I think I think I will choose a box plot. So I'll choose data on that axis, on the horizontal axis, and then I'm going to choose box plot. And there we have a box plot occurring. Now, at the moment, I'm going to say that effectively this is what I want my widget to do. So what I'm going to do is save this appropriately for a widget. What we have to understand is a widget is a single page, just a single page that we write ourselves, construct ourselves, and that we can recall at any time and put into any random document. So at the moment, as you can see, I've actually started off with 3 pages for this widget. So what I'm going to do is group them together. How do you do that? I'm going to go back to the first page that I created, which is the Lists and Spreadsheets page. If I go through the menu system, go through the Doc button and the menu system through the Doc button, if I go Doc, Page Layout, you can see there is an option here that says Group. We can use this to group our pages. So if I hit Group, it actually groups the first 2 pages together. Now, if you actually had noticed what beside that option there was a shortcut, Control 4. So if I actually now press Control 4 on the handheld, it's a lot quicker to actually group the pages. So now, as you can see, I have grouped those 3 pages now onto one. What I need to do now is save this as a widget. So if I go to my handheld and press Control, Save, and this is important, what we need to take notice here. At the moment, we would be used to saving things into the My Documents folder here. But what we need to do is go and find the folder called My Widgets. Now, for a lot of us, there would be a fair chance that we've only got the one folder when we actually, or one file in My Widgets, which is the stopwatch. I've actually created lots more than that. And so, in fact, I have got quite a lot of widgets in here. The stopwatch, though, there's the stopwatch. You'd only have the one file, possibly. So the first thing is to just double check that we are saving into My Widgets. The next thing is now is to call this something sensible. I would probably call it the univariate statistics. I'll show you my naming convention in a little bit more detail shortly, but I'm going to just call this, for simplistic sake tonight, AAA, and I'm going to save that. And as you can see now, it's been saved as AAA. I've now created my first widget. Now it's time to put this to use. So I'm now going to pretend that I'm one of my students and I'm doing a test and on statistics, and I'm going to open up a new document. And I've looked at the first question, and straight away I can see that, in fact, the first question of my test is on univariate statistics. So I know that my teacher has, in fact, given us a widget that could help us in actually answering this question. So instead of adding the well-known pages that we're perhaps more familiar with, instead I'm going to add a widget. And the widget that we are looking for is the one that we've created, which is AAA. So I'll highlight it. I will press Add, and there you go. I've now put the widget into this document that I've created. The only thing is it's not very useful format there because it's all in one page. I need to ungroup the pages. Now to ungroup, if I press Menu, not Menu, wrong button, Doc, Page Layout, I can ungroup the page by choosing, or pages by choosing that option there. But as you can see, there's a shortcut to ungroup, which is Control 6. So if I choose that, all of a sudden now I've now ungrouped those 3 pages that I started with earlier. Now what I'm going to do is perhaps clear this data.
Just on that, Craig.
I'm now going to, let's pretend I'm doing a test question, and I'm putting some numbers in relevant to the test question. I'm now going to go on to the next page. I need to now activate that particular maths box here. What I'm going to show you is a button sequence that would use if in fact you've got lots of maths boxes to activate all at once. I've only got the one, but I'm going to pretend I've got more. What I encourage people to do is press Control-A to select the whole page. And then if I press Menu, 1 and 1, that will activate every maths box that needs to be activated on a notes page. And as you can see, there is the results calculated for us on that bunch of statistics. And then lastly, if I actually go over to the last page, I can view my box plot, which if I hit the zoom data, you've got to remember just to hit the zoom data every time you in fact put new data in there, because it has to readjust the axis to fit the information. Now what I'm going to do is show you the fact that this widget could be improved on. So I'm thinking that's useful, but I want to in fact improve that widget. So because the widget's actually a file, we have to remember that we need to access the original file to make changes. And so when you open it, you have to make sure that you go to your documents, TI-nspire and make sure you go to your My Widgets folder, and we have to open up the original file to make changes. So I'm going to open up the original file. There's the original file, as we can see. I'm going to press Control-6 to ungroup them. I'm now going to make some little changes to this particular page here. At the moment, I'm going to press Control-A, Menu 1 and 1 to activate that maths box. That's what we had before. Okay, how can I improve on this widget? I'm going to highlight that maths box. You can see it's, I've clicked on it, you can see it's dotted in a red dotted line around its outside. If I press Menu, oops, sorry, oh yeah, Maths box options, Maths box attributes. I am going to hide the output of those results. Now straight away I'm thinking, why would you want to do that? But trust me, you're about to be amazed what we can do, hopefully. I'm now going to click off that and I've hidden all the results. Now what I'm going to do is come down here. I'm going to draw a line underneath this and I'm going to type in do not alter below this line. Chris said he does this to remind his students not to alter anything under this line.
I think that's a great idea there, Craig.
Sorry?
I think that's a great idea to do that, so, you know, then they know not to touch anything below the line.
I agree with you. I'm learning from the master, someone like yourself, mate. All right. How can I, in fact, improve on this? I'm going to type in the word mean. Notice I'm not in a maths box. This is purely a note. So I'm going to type in mean. Probably should actually say sample mean. Oops. I'm no good at typing, as you can see. Sample mean, and I'm going to put a colon and a space. Sample standard deviation. We're running a little bit short of time, so I'm going to perhaps use a bit of some abbreviations here. Maybe a minimum, lower quartile, median. I'm going to actually go straight away and go with the range here, and I'm going to go with the interquartile range as well. So these are all notes just to basically illustrate what the results are going to be. I'm now going to go up here to where I've got standard mean, and I'm going to press Control M to insert a math box. Now when we calculate our results, a whole lot of variables get created, and if I hit the variable list, I can come up with this whole list of variables, as you can see. And what I'm going to do is I want to put stat.xbar, which would actually be the result for the mean in that maths box there. If I press enter, there's the result for the mean. Now I'm going to repeat this for the rest of them. So I'm going to press Control M. I'm sorry if I'm actually speaking a little bit too quick. So don't forget this is recorded, and when it comes to doing this in your own time, you might be able to pause. But I'll try and get through this as I am starting to run out of time. Sample standard deviation.
So Craig, just
sorry,
as
Chris?
You're doing this, just people who are listening just have to realise that we expect the students to set this up before they go into an examination task. And then when they see the final result, they'll see why it's important to put in the effort beforehand, and then it'll pay off in the exam. So we'll just have to be a bit patient with the setup, and then once you see the end result, it's going to be brilliant.
Absolutely. So the hard work, the preparation beforehand is the key. So lower quartile. So as you can see, we're getting some results coming up. Here with the range, I'm going to put, again, in the maths box. Now the range, of course, is the maximum value. So I'm going to go maximum, which is there. Take away the minimum. So if I go with the minimum, so there's the range calculated. Similarly for the interquartile range, so Control M again for a maths box. It's going to be the upper quartile called Q3, take away the lower quartile. Oops, I've lost the plot. Try that again. It happens. Q1, and you could naturally see we could keep on going and putting a lot more results. The one other thing I would do is actually I would hide all the inputs here, so just the outputs would in fact be showing, and we can do that all at once. If we go up to this line and actually highlight all those lines, if I now press Menu, Maths Box Options, Maths Box Attributes, and if I now hide the input of all those maths boxes and press OK, now if I click off them, you can see that that page gets tidied up somewhat and where it just displays the results. Okay, I'm going to decide that that's my new and improved version of AAA, but I need to actually save it. So first of all, I'm going to press Control Save, make sure I don't do anything silly and lose all that. I'm now going to go back to the start and I'm going to group the pages. I must group them again and save them as a widget, otherwise the changes will not be reflected. So remember the shortcut, Control-4 to keep grouping the pages until they're all grouped together. Done. One last change of Control and Save to save AAA. There it is. Okay, I've got my new and improved version of AAA. So let's see if in fact those changes have been reflected. So I'm now going to pretend again that I'm doing a second test. So new document, a second statistics test, and I've got to a question where I've got to use my widget. So I'm going to open up my widget and I'm going to find this widget called AAA, press Add, there it is, and now what we're going to do is ungroup. There they are ungrouped. I think I will clear the data, punch some numbers in. Let's get the statistics of those numbers. So as you can see now, This is the notes page. I'm going to press Control-A to select all, menu, 1, 1, and the magic happens. As you can see, there's the statistics on that information that I've entered, and if we want to have a look at the box plot, we can have a look at the box plot and zoom data, and there we have it. Okay, so that's basically how you create a simple widget. Before I sign off and hand over to Chris, there's just a couple of little things I might want to should cover with you, and just show you what else is possible. I'm going to insert a problem, so I've finished with statistics. I'm going to insert another problem on this file, and I'm going to show you another widget, which I've labelled for tonight, A quadratics. I've labelled it A. If you actually have a look at, if you put some thought into how you name your widgets, they come in alphabetical order like any filing system. I teach further maths this year, so I've got them called FMBV for bivariate, and then what they do, FMTS for time series, and then what they do, and FMUV, what they do as well. So that might be a little hint as to how you might put some thought into naming your widgets. Let's go back to quadratics, so I got a little bit sidetracked there. A quadratics, let's add this. What does this one do? So we've got here the general form of a quadratic. As you can see, I'm going to split the pages like I did before. I'm going to go Control A, menu, and 1, 1 to activate everything. And so what does this do? Well, we can play around with values. We can play around with values of A, B, and C, and you've got the general sort of the results being calculated there. You can see the intercepts, turning point, completing the square version, factorised version, appropriate. Notice I've also got the discriminant also being calculated here, which means, of course, over here you've got the relevant graph also being plotted.
That's amazing, I think, Craig, that without having to go to the graph page, insert the equation, it's all automatic.
Yeah, that's exactly right, Chris. Inserts it automatically. Some people might be a bit of a fan of actually keeping these two pages actually split on the one page. With the handhelds, though, with the kids, the feedback they give me, they don't like it so much, so split them, but that's actually personal choice really too. But in something like this, you can then start playing around with values of B, of course, which might in fact lead to, you know, perfect squares for your discriminant, and you might want to maybe investigate that in terms of what that might mean in terms of solutions. But you know, that's just a little bit of a thought, but a really nice little widget that you could have lots of fun with exploring some maths. And probably the last one I'll demonstrate, and this is something that's come hot off the press today, that has been emailed to a few of us. Couldn't believe the timing of this. Sean Bird sent a great idea out to Peter Flynn and I think Peter Fox and you too, Chris.
Yep,
and that is using widgets to display the shortcuts that we often use and sometimes forget when using the TI technology. So what I did do is I started one off. So if I head into, I'm going to insert another problem.
So just as you're inserting another problem there, Craig, it's, if everyone's noticed this, Craig inserted a new problem, and you could think about it as like exam questions. This is question 1, this is for problem 1, question 2, problem 2, question 3, problem 3, and they'll call in a widget or a user-defined function depending on the question they get, and they'll have the option of 2, but they've started a new problem for each question, which means they can also go back and they're not going to overwrite any formulas that they then bring in which might have the same variables.
That's right, the variables in problem 2, so if I go back to problem 2, you can see the variables I've created here, and if I hit the var list, you can see there's the variable list for problem 2. if I go across to problem 1, we know problem 1 was everything about stats. If I hit the var list, oh, hang on, I need to go across to there, to the notes page. I hit the var list, that's a completely different set of variables. So you can see that problem 1 has got absolutely nothing to do with problem 2. So it's very useful to keep that in mind. So if I actually go and insert this widget called shortcuts, this is what I'm sort of trying to talk about. So there we are, shortcuts, a list of shortcuts. Control 7 to go up to the top of the page, Control 1 down the page, Control 9 up one screen at a time, Control 3 down a screen at a time, Control A to select all. You've seen me use that tonight. So there's a few shortcuts you could add that you've seen tonight in terms of grouping and ungrouping pages, but we know there's shortcuts that exist for inserting the derivative template and the antiderivative template. You could go bananas in actually creating that particular widget. So I hope I haven't gone too quickly tonight. I know I had a lot to cover, but I hope that, in fact, this gives you some really good ideas to take away and experiment with your classes. And I think now, Daisy, it is time to hand over to Chris. Take it away, Chris.
Okay. So I think everyone has my screen now. So thanks for that, Craig. There's some great stuff in that, and the session that Craig ran in at Baltimore was wowed by widgets, and all the people over there thought it was amazing. So what I've got here in the file now, what I suggest you do with what Craig and I are doing tonight is you go back, look at the video over a cup of coffee, go through part of it, and another day do a part, because there's quite a bit there. So all these files that we have here, you'll get them on the website, and so we've got some instructions. So a user-defined function is just something that you can use. So if you're trying to find maybe some graph information that Craig was showing with his last quadratic example, you could have these all pre-set up beforehand, before people go to assessment task, and then you use them. So a user-defined function is just set up in a different way. The calculators page or a notes page can be used, which Craig was showing the notes page there. And the first type that we're going to do only works in the current problem and the current document that we use. So we've got a whole lot of instructions that are here that you can read as a leisurely pace there. So we might just flick through those for time's sake. And this is using version 4.5 of the software. So the first one that we might have a look at is just Pythagoras' theorem is something which is interesting.
Sorry, so, excuse me, Chris. Sorry to bother you, but could you just share your screen?
Oh, it came up.
I was just wondering if that was me or you, Chris. That's good.
No? Oh, it came up before.
Yep, you got action there, mate.
I got action?
All good.
Thanks for that.
Oh, good now.
All right, I'll just flick back. No, I did press the button and it looked like it came up, but it didn't. All right, thanks for that. All right, so just going back to the title there, as I mentioned, we've got some instructions here that are all there in the first few pages that explain everything that you've got to do. Just read through it at a nice leisurely pace there. And if we want to start with the first question, this is just a notes page. So these work on both notes pages and calculator pages. So to put in the maths box, as Craig was saying, it's Control M. And if we go menu menu calculation, we're on the notes page. So we've got our define, we put that in. And what we're going to do is we're going to call this Pythag. It's always good for you to call it something that you know that it is. I'm going to call it number 1, and we're going to put it in, and we're going to do something a bit different. We're going to go solve, and we've got our a squared, b squared equals c squared. Okay, but this time what we're going to do, we're actually going to go and say we're going to solve for this, the question mark. And when we press enter, it says that it's done. So that's our first user-defined function. Now what we want to do is we've got a problem that we're going to do, which is find the unknown size. So as Craig was before, you just press the var button, and all you have to do is enter the information. About the only thing that students need to remember is the order of their user-defined function. So when they're in the exam and then using their calculator, they could have a summary sheet that's in there. So I'm just going to put in 5, comma, question mark, and the 15, comma, 15. And we press enter, and not a function. Oh, that's very interesting. All right. Function. Not quite sure what happened with that. So let's just have a look here. Okay, what I forgot to do was actually tell the calculator. Okay, so that sharing the screen thing has sort of thrown me off a little bit. Now, students should always try their functions regularly. So if I go back to 1.5 and I forgot to tell the calculator about the 3 variables that were in there and put it in and close our bracket, it will now automatically update our rule. And when we go to our 1.6, we have our answers. Okay, so it'd be interesting to see if anyone's used the question mark. The question mark, it saves us having, say, a rule that worked out A, B, and C in 3 different things. The next thing we might want to look at would be what would happen if we had a UDF. Now, you notice this one is on an actual calculator page. So we're going to, again, default, menu, actions, define, and we're going to say this is Pythag2. So I could, if I wanted to, I could just edit Pythag1 and just put a 2 there, which helps me with some of the syntax. And remember to put my parameters that I'm actually entering in. And with this time, I'm just going to go back and I'm going to delete the define. And I'm going to use the control assign key. This is the assign key, which acts like a define. And we're going to go solve. And again, now I suggest that people do this, students and teachers, they do this on their handheld, because we can go through and we can copy and paste from other user-defined functions that we've written. And so if I did do that, if I went back to my 1.5, I can actually copy this part out. Control C, copy. I can go back. And if I was a student, I would be doing this on my software and paste it in. There it is. And then the other thing I'm going to do is I'm going to put my question mark in, and I'm going to say that it is greater than or equal to 0. And then if we go across and we want to go comma, and we want to solve for the question mark and press enter, and it's done. And all we have to do now is we're going to check that thing again. We see that we've got 2 defined functions at the moment, so we pick Pythag2, and we're just going to put in our answers again, 5, comma, question mark, comma, and 15, and press enter, and this time it gives you 1 answer, so that helps. So again, press the var key to see what you've got stored, and it's all good. So we could go through and work out gradient. Now, what a student would do, he'd be looking at past exam papers and seeing what rules are used regularly, and then going up and designing his own. So these are just some simple examples just at the moment. And again, we're on a notes page. So these work on a notes page or otherwise. If you're on the computer, you can type in your things, and we're just going to call this grad M. Okay, and then we're going to be putting in each of the variables, x1, comma, x2. Now, this is the thing that you have to decide. How do I put them in? Will I take them as pairs and go x1, y1? Or will I go x2, x1, x2, y1, y2? I'd probably suggest it's better to put them in as you would read them off as coordinate pairs. And then equals, and we'll use our template. And then our y2 minus our y1 over our x2 minus our x1. Now, we see that it takes quite a while. We press enter and it says done. Quite often students come in and they change something in here when they're doing these, and then they forget to actually press done. They move on to the next bit and they say, why hasn't it worked when I actually type it in? So it's important that they press enter before they leave and they get the done coming up. So that's our next one. Again, if we press VAR, there they all are. And we move on. Now we're going to test our user-defined function with what we've just done. Hit the var key, press your greater than M, and we just put in the values, 5, 2, and it's really quick for the students to type them in once they've got them set up, as long as they know what they're doing with them, and there's our answer. Quick and all done. Okay, Craig, do you use these much?
No, I am having a sensational time watching you wield your magic, mate. This is good. Okay.
Now, you notice I've got this next one, which is called line 2P. And if you have a look, I haven't actually, it's not registering there, because what I did was I actually deleted these off just to show you to save a bit of time putting it in. So we've got this here. Now, if you find that someone's deleted it by mistake, all they have to do, we're on a calculator page, and all we have to do is up arrow, highlight it, press enter, and then press enter again, and now it's reactivated the formula and put it in, and there it is. It appears line 2P. Okay. So that's important that people know about that. So we've got our equation of a line, which people will use quite regularly, and if we just scroll across to the syntax, and we want to solve for y. So it's going to end up in y equals mx plus c form. All right, so we just want to test it. Now, it's very important that students test these with various values, because I've written a couple where I thought it worked, and it worked for this set, but when I tried it again for a different set of values, it didn't work. And so they've got to extensively test these before they go into the exam. So we're just typing in the values for x and y, and once we do that, there's our equation. Not a problem. It's all up and done. So I think that's a bit of a wow factor. Students don't have to worry about writing solve, type in the equation, division template, etc. So I believe it takes saves a lot of time for them.
Excuse me, Chris.
Yes.
Will that work if you put a parameter in for one of those points? So swap the 9 for the letter B.
Okay. So let's just say a student did make a mistake typing in the coordinates, and we could just go up arrow, press enter, highlight the section that you want. So if we just delete that off, let's just clear that off. If I just press up arrow, highlight that, press enter, and then let's just say that the 2 was supposed to be a parameter, and we put in A. Now, we've got to be very careful with this. I'm not going to choose that. I'm going to choose something that I know I haven't got anywhere in my variables list, because it may do something a bit strange. But this is a local parameter, so I don't think it will. So let's try the A anyway. So there it is. There's your equation in terms of A. Okay, so
thank you.
This is, Craig, that was good. That worked. Thanks for that.
Oh, beautiful.
And there's more you can do with that. So what we're doing this time is we've got this equation, find the equation of a straight line passing through A, 3, 6, and B, minus 5, 9. This time we've got to do it in the form ax plus by equals c. So we're still going to use our usual line 2p. We're going to put in our 3, 6. Now, very quickly, once you've got it there and you get familiar with it, you put these in rather quickly, even on the CAS calculator. I actually find that the CAS calculator is easier to put these values in rather than the keyboard when you're actually using it. So we've got that in. Now, the trouble is the student says, oh, man, it's not in the right form. So some of us do not know that CAS was supposed to solve our algebra issues. So if I actually go times 8, it gives me this. And then all I have to do is, rearrange the equation that's there. I might say, expand, I guess. Let's try expand. And again, I've got my brackets. If I up arrow this time, I can just press enter now, and it puts it inside the brackets. If I press enter again, there we've got it here. Now all I have to do is, if we set it, what we do in English, just add 3x to both sides. And it solves the answer. And there's our rearrangement. So we can do some quick algebra by just doing that. That's the syntax for doing that sort of thing. All right, so moving along. We want to find the unknown ordinate if the equation of the straight line passing through the points A, -2, 5, and B, 4P. So this is what you were talking about before, Craig, when we put parameters there. So we just have a think about it. What might we do here? So this is a notes page. So what we have a look, we go to our variables and we go back, oh, it's got something to do with my gradient formula that is there. Okay, so we're going to work out the gradient, and we put in our -2, 5, and 4, P, and we're going to get an answer there. That's our answer there. Now what we might say now is, so we've got our gradient in terms of P, we have to solve this with being -3. So we should put in another maths box, Control M, for a maths box, and we would type. Now, just remember, when you go to our menu, because this is what the students will be doing, all these things that we're used to now appear at number 6, and then it looks very similar to what we had before, but the first thing is number 6, so we want to solve, and we want to solve our gradient. Now, we could just type in the P, -5, or what I really want to do is I want to actually type this in. So I could just copy that, and because what we find out very shortly is that we can now say that this is going to equal -3, and we want to solve for P, and then hopefully when we press enter, it will give us the answer. So what we've got here is our user-defined functions that we write. We just have to be very careful that we test this beforehand. They can be used in solve or expand or anything else, so we can actually incorporate them in solving equations, which I think is really exciting with that. Now, I think when you go with Craig's widgets and a combination of user-defined functions, I think we've got a winning thing for solving questions in assessment tasks very quickly. Now, just down the bottom, I thought I would do a slightly different way of doing it, and a student might have said, oh, I could just equate the two equations that are there using my line 2P and solve for P, which gives the answer down here. So you still get the P equals -13. So I was thinking of solving the two equations, so that will work as well in that. So the first one was a much more straightforward solution. Okay, now I'm just looking at the time there, and we're now moved into, as you see up the top here, this is now 2.1, and if I press the var key, as it says there, I have nothing. So all the functions that we just did only work in problem 1. When we go to a new problem, it's like we have a blank document, it all starts again. So what we could do is, I'm just going to go through a few things here just to show you what you can do with matrices. And I'm going to bring up a different file here. So this file that you get that have all the answers will be on the website. So we're just going to go up. And here we are, functions and matrices. So if you remember, Craig, so what we're going to do here is we're going to consider these points, and we want to write a UDF that calculates the distance between the points in the equation of the straight line. So we could do that, not a problem. And what we've got is we've actually used a matrix so that we can get more than one piece of information out of the matrix. So there's our distance formula. So to put in a matrix, what you're going to do is go to the template, is one of the easiest ways here. We could go here and click that one, and then we just choose. Now, you'll probably, let's just put in the 3 rows, but we're probably only going to have 2 columns, which are there. So we'll just select 2, and then we're going to fill in the information we've got there. So we just go in, and if we've got 3 things there, you put it in, you might have more. So that's how you put the matrix in, a little bit of play. Again, if you notice the syntax, there's no solve here. It's a totally different looking syntax, because you'll have to try to see what the output comes, and quite often it'll say syntax error, because it might have, if you're doing zeros, it puts it in an array, and it doesn't like that because it's just like a matrix itself. So you just got to check the syntax out. I'm just going to highlight a few things that we might do here. So we've got our 2 points. So if a person was going to do that, they would just say, oh, I've got a UDF to do this, and they'll just hit their var key, and pull up their 2 points, and just type in as quick as they can their information there, and then they get the information coming up very quickly. There's our answer. So the only thing students have to realise, this is y equals. So if you wanted to in the text, you could actually include y equals, line y equals, and play with it around like that. Now, if you remember, Craig had a UDF about a quadratic, and I thought that was a good thing we could do. Now, there's just a little note here that sometimes I find, oh, my matrix was really good, but I need to add one more thing. And if we use this arrow key, which is down here, we can actually add an extra row. If you wanted to add an extra column to your matrix, but I don't think you would, you go Shift and that button. So that's a couple of things to note there. So this one looks rather impressive. So what we've got here is we've got a matrix which has all this information about some graphs. So I'm just going to go across here. Now, if I hit Control 7, it'll go to the start over here. And if we just arrow across, come on, arrow up, you do notice that the notes page and the calculator page work in a slightly different order about viewing as well. So this one's called 2 points, but I've just added the gradient, distance, the midpoint in the x, the midpoint in the y. We've got the line, and we've got solve works in this one, so that was an interesting one. And you've just got to be careful of the output, and we've even got the normal line which comes there, and it'll all be in y equals mx plus c form. So again, all the student would go to is to his var key. We see there is a 2 points one there, so we'll just go out. So all that we really did here was come up and go var, there's my 2 points. All I want to do is now type in my 4 pieces of information, -1, comma, 7, comma, 6, comma, and -2. And there it is, all done. Very quickly as that, and the student will just read off the question what he needs. Now, having it in the matrix is not always the best way of doing it. So I'm just going to quickly go through and show you something with the second part. This is, again, there's some instructions there, very similar to the first part, but this is something which is stored in your library. So I'm just going to quickly go through this here. Now, what we do is, when we did our line 2p before, we didn't have this libpub in there. You must use define. You can't use the colon equals, the assign key, to do these, because it will not store in the library. So you just put libpub in all of your functions that you've written before. Once you do that, what you have to do is you have to save this file. It has to be saved in the mylib folder. We'll get to that shortly. The other thing that you've got to do, and the instructions on the previous page, you've got to make sure you can only have all your user-defined functions in problem 1. The calculator will not read anything in problem 2. So it's got to be all in problem 1. It doesn't matter how many pages you have in there. Okay, so I've got lots of rules. These are all the rules that we did before. So all I've done to all these rules, I've made sure it's got defined. I've got libpub in there. And they're all the rules that we've got, that we did before. And there's some more on the next page. They're there. Okay, so they're all there. Now, the only thing you've got to do is you'd have to save them. So, File, Save As, and it's in My Documents. You just have to scroll down till you find My Library, My Lib, open that, and you'll see that I've already put it there. So, providing it's in this folder, it's stored, so I'm going to cancel that. So we assume that I've saved it there. And then the next thing you've got to do is to tell the calculator that you've put something there. So the next thing, this is all in the instructions on the earlier pages, you just have to hit Refresh Libraries. And what Refresh Libraries does, as you add new functions, as you think of them and you put them in, it then adds them to that to the menu where you see how to get them. So it puts it in the catalog I was thinking of, and it's in my library in the catalogue, which we'll get to in a minute. So you could write them just here. I have taught specialist maths for a long time, and these are just a couple of the ones that I've done before, and I just put a few in here. There's the magnitude of a vector, the dot product, the scalar resolute, and it's there, and that's the last page there. So I just thought we've just got time, and I'll just show you a couple of questions, okay, about how you might do it. So these are some questions, okay. So we want to find the equation of a straight line that passes through straight line that is perpendicular to this equation and passes through 712. So we're just thinking now, what have I got? Now if I hit variables, there's nothing there. So we're sort of saying that's a little bit annoying. There's nothing there. But the first thing we might say is I've got to find a line perpendicular to this. So I might go through and go solve and then type in my equation. I can, if it's in the question in a file, I can just copy this and go Control-C, and then I could have just pressed Enter, and it puts it down there. I want to put it in y equals mx plus c form, so I'm going to solve for y. There it is. Student then remembers that the gradient of the tangent line is the negative reciprocal of the gradient of this line here. And then you say, well, to find out where this function is, I go to my catalogue, but I go to number 6, which I would probably suggest a lot of people haven't really used. This is what we saved in our catalogue, in that's the My Library folder. All I do is hit the plus, and I scroll down. These are all the functions I showed you that were there, and we want to go through and look at our line 1p. So the line 1p is a function that I wrote to, you know, a point, and you know the gradient, and it should give you the equation of the line. So we're going to put in, now I've put in the order point and then m, gradient. So it gives an idea of what you're putting in. So if we put in our 7, 12, the gradient, which will be negative 3/5, it will then go through and give us the equation y equals mx plus c form. So that's all good. We probably have time just for one more question in that. So I'm going to open up this file, and I'll just show you a couple of things that it can do. Again, you play with it. Now this midpoint one is an interesting one that you see there. It gives me all the midpoint values, and it gives it as an array. You've got to be very careful if it gives you an array, because when you come to do a question, so we're finding the midpoint of these 2 points, we've got a parameter in there for A, we've got a parameter for B, but this was probably the most awkward one to try and do, and a little bit complicated in there. So just to fill it, just to do that. All right. Now, just going back to Craig's idea, he had something like this that was there before, and we've got to sketch this graph. Now, all we do, again, if I was going to do that, I would just go into my catalogue, I would go over here, make sure it's on number 6, I put this down, and I look for the appropriate one, and this one I believe was called info. So we click that, and then we type in the appropriate rule that is there. I'm just going to copy that since it's there, and paste it in here. You have to copy and paste if you're on a notes page. You can just press enter on a calculator page. So I'm going to paste that in, and again, you just press enter. There's all your information. Now, if you notice, Craig had a widget. Now, the widget, he basically had similar information on there, but he was able to, on the next page, when he ungrouped it, or you could see it on his split screen, he had the graph. So I think having the graph, if a student's supposed to sketch that up. Now, Daisy, I think that's about all I've got time for. So if we have a look, this is one of my favourite ones, because we all know about scalar resolutes, and they take a lot of time. The student just has to fill in the 6 values there. It gives you the scalar, but the piece de resistance is a question which says, if I know what the scalar resolute is, and I have a parameter in one of the vectors, I can actually include in a solve feature my UDF about my scalar resolute parallel that we just showed you in the last slide, and I can put the parameter in, say that it equals root 70, and then it will solve it for you automatically. So I think that's where the UDF comes into great importance, and that is very similar to the Year 12 Specialist Maths exam from, I think, a couple of years ago. So I'm going to sign that off there, Daisy, and it's all yours.
Well, thank you both, Craig and Chris, for that great session. I certainly got something out of it, and obviously it does help students in the exam situation. So thank you, audience, for listening. Thank you to our wonderful presenters. We wish you a very good evening, and as I mentioned, you will be requested to provide some feedback at the end of this session. So please go ahead and give us your feedback, and your certificate link with the connection to the resources will be sent out in the next 48 hours. Thanks again, and have a lovely evening.
Good night.
Good night.